Okay, so we're getting down to the last operations on this last part of the project, the carriage stop project. I'm going to use a dividing head to cut the graduations in the thimble. Okay, we have two different length graduations, every thousandth of an inch. The graduation is 160 thousandths long. I don't know if you can see that or not. Let's see. There we go. The thousandths divisions are 160 long, and in every 5 thousandths we have a line that's 230 thousandths long. I probably should have put how many graduations there are on here, but I guess you can see a 40 sneaking up on the back side in this view, so that means there's 50 divisions all the way around. That goes with our 20 pitch thread we're going to put in the center, 7/16 20. The lead on a 20 pitch thread is 50 thousandths, so one turn moves the stop 50 thousandths of an inch, hence the 50 divisions. So a dividing head is the best tool to use for this, because it's easy to index a dividing head for evenly spaced holes. The way the thing works is it has a crank on it, and the crank turns the chuck at a 40-to-1 ratio. Okay, then you have all these plates you can put on with different numbers of holes in them, and by playing around with that 40-to-1 ratio and the number of holes here, you can space out pretty much any number of holes. Okay, then it also has this gauge thing you can set for going partial turns, maybe 3/5 of a turn around or something like that. You can set this thing up, and then the crank has a pin on it. It just drops into a hole, and that's how you index the chuck. Okay, you can do the same thing using a rotary table. We could mount our part on a rotary table, but then you'd have to figure out the angular distance between each graduation, and it would get pretty painful to work your way around. So this is the best way. It could be done on a dividing head or on a rotary table, but I'm going to use a dividing head because I have one, and I'm going to show you how to set the thing up. First of all, we got to get the thing vertical, right? When I put it on here, it was horizontal, so I loosened the lock nuts up, and we have to make sure it's vertical. So I'm just going to throw a piece of ground rod into it, and we'll run an indicator along this rod, and we'll get the head vertical, and we'll also get it on the center of the spindle. So let's get going on the setup. Let me zoom in a little bit so you can see what's going on. Alright, should be able to see that a little better. I'm going to be changing camera angles a lot in this project, because there's so many things you need to see that are in different fields of view. So it's going to be a lot of transitions in this video. Okay, so what we're going to do is we're just going to run the indicator up and down on this shaft. As we adjust it to vertical. Okay, we can see you have quite a bit of travel here, so let's just bump it up a little bit. Alright, I think we're bottomed out there. There we go. Alright, we should be getting pretty close here, I think. Yeah, we froze the indicator up again there. Alright, now we're close. This is kind of critical in this part because the graduations are only 6 thousandths deep. So if we got a 6/1000, if our parts, or if our dividing head's 6/1000 out of alignment vertically, then your divisions will go away. Alright, so we got that lined up. Let's lock it down. Okay, now let's check the concentricity of the chuck on the index head, okay, or the dividing head. This is a little bit painstaking because you have to rotate the chuck. Like I said, it has a 40-to-1 ratio, so it's kind of slow. But this is also kind of critical because if we have, obviously, if the graduations are 6/1000 deep and you have a 6/1000 run out in your part, you're going to have graduations on one side but not on the other. And as it turns out, that's exactly what this is, a 6/1000 run out. So let's adjust it so it has a lot less run out. Try and get it under 1,000. This is a buck chuck on here, and it has dividing or adjustment screws on the outside of it. You can just slide the chuck around on its backing plate. It's really handy. Alright, that's pretty close. First try. Let's see if we can't tweak it in a little better. I'll have to admit it was indicated in before I put it on, and I just tweaked it, so there's only 2 screws that are really out. And we're close. We're within 1/1000th of an inch. Let's see if that does it. Okay, right on the money. Alright, I don't see any run out at all on this, so that's pretty good. Okay, so the next thing we need to do is we'll just mount the part in here. This guy here, got it all cleaned up, took the rest of the burrs off, and looks pretty good. And like, if you remember, we put a 3/8 hole in it. Okay, so I'm just going to put a mandrel in the hole, and we'll use the mandrel to hold on to the thing. The mandrel's tapered, so you can just tap it into the hole and it locks on nice and tight. And then you just hold on to the mandrel with the chuck. Okay, that's how we're going to hold our part. Now we have to mount the tool. Remember, we made this tool when we were making the body of the carriage stop. We ground this 30-degree V-shaped tool, and we scribed the line in it, the index mark on the body. And that's the same tool we're going to use to cut the divisions on this thimble. So what I'm going to do is I'm just going to mount this in a collet. Yeah, that's not going to reach. I'm going to have to put that mandrel in a little farther so it doesn't stick out the top. Let's go the other way. What I'm going to do, I can't quite get it in with the hammer, so I'm just going to go over to the press and press it in. I'll be right back. Okay, nothing like a 20-ton press to make sure a mandrel goes in as far as you want. Okay, now that we have the dividing head vertical and the chuck concentric on the dividing head, we have to center up the spindle on the chuck, okay? So let's put in, I'm just going to use an edge finder. You can use an indicator if you want. This is a lot quicker and works pretty well. You've got to have some power for this one. So I have another video out where I found the center of a hole with an edge finder. This is the same principle, except we're finding the edge of a cylinder. Run up against the side of it. Zero out your readout. Or the dials on your table, whichever. Pick up the other side. And split the difference. And do the same for the y-axis. Actually, we don't even need to center the y-axis because we're just going to cut these graduations 6/1000 deep. We don't care what the dials say. All we're going to do is touch the part and move it 6/1000 and cut all the divisions. But it's all centered up now. All right, let's get the tool out here. The tool is the same one we used to cut the index mark on the body when we made that, if you remember this. It's just a 30-degree tool that we ground out of 01 drill rod and hardened. So I'm going to use the same thing on this job to cut the graduations in the thimble. So this thing is a 1/4 inch piece of round stock, so we use a 1/4 inch collet. Raise this up a bit. Okay, what we need to do now is rotate the cutter around till it's situated or oriented like this. So I'm going to cut the graduations on the front side of the thimble. So that's not a super critical alignment, but all I'm going to do is use a protractor up against the side of it. Then I'm going to sight down the protractor. I have a parallel on the table, squared up to the table. I'm just going to sight along the edge of that parallel. Be plenty good for what we're doing here. So let's get this over near where the parallel is so I can just sight down next to it. And I'm just going to push the protractor against the side of the tool, and I'm going to rotate the spindle till the blade on the protractor lines up with the parallel down below. Not everything has to be super precise in machining. A lot of times you can get by with just eyeballing something like this. Okay, now we're lined up there. I'm going to lock the spindle so it doesn't move on me. And we'll go back to the center of the dividing head. Out there. Okay, this exercise is a good example of how much setup it takes for some jobs. The actual cutting of these graduations isn't going to take that long, but there's a whole lot of setup that you have to do before you can cut anything. Okay, let's see here. Alright, now what I'm going to do is I'm just going to bring the table up, use a piece of paper as a feeler, and just set the end of the tool even with the top of the part. Okay, now I'm going to set my dial to 0 on the knee, and I'm going to raise up 230 thousandths. We're going to do the long ones first, the marks every 5 degrees. So go up 230 thousandths. Okay. Alright, now that we have the dividing head set up, aligned, and the tool aligned, let's talk about how to set up the dividing head to cut our 50 divisions. Okay. I'm going to change the camera angle for that so you can get a close-up view of this, the index plate on the front of it and the crank, and I'll show you what we need to do. So a dividing head, this dividing head, and like most dividing heads, have a 40-to-1 gear ratio on them. In other words, when we turn the crank 40 turns, the spindle will rotate 1 turn. Okay, 40-to-1. And that ratio is important because that's the ratio we use to calculate how many turns or percentages of a turn, fractions of a turn, we want to turn the crank to rotate the spindle so that it cuts the number of divisions we want. Okay, in this case we want to cut 50 divisions. So the way we figure out how far to move this crank is we take 40, the number of turns to go all the way around, and divide it by the number of divisions we want to cut. So that's just a simple fraction, right? Take 40 and divide it by the number of divisions, in this case 50. That reduces to 4/5. And what that is that means 4/5 of a turn on the crank. To move 1 division, if we want to mark 50 divisions all the way around, 4/5 of a turn will move 1 of those 50 divisions. Pretty simple, really. If we're cutting fewer divisions, that number would be maybe 1 or 2 turns plus a fraction. Okay, but in this case we're turning a fraction of a turn, so in fact 4/5 of a turn. So then how do we do that? How do we know when we move 4/5 of a turn? Well, you look on, if you see this, there's a number of different hole patterns on here, and each one of these circles has a different number of holes around it. So what we need to do is with that 4/5 fraction in mind, we have to look at these numbered circles here, and we have to find one that both the 4 and the 5 go into equally. Okay? Down here we have a 15 hole circle, here's a 16, 17, 18, 19, and 20. The only circle on this plate that 4 and 5 will go into is 20. So we're going to use the outer circle. Okay? Now if we want to go 4/5 of a turn, 4/5 of 20, well, let's see. 5 goes into 24 times, so 4 times our 4 gives us 16 holes. So 16 20ths is the same as 4/5. So we need to set our little stop thing here. Let's start. I always like to start at the top hole. First thing I need to do is loosen this crank and get it in that outer circle. Like that. Okay. Now we'll pick a starting point. Let's call it right there. And I always like to put a mark on that point. That's my starting point for my number of divisions. That way, if I get lost, or I think I get lost, I can always go back to start and check myself. Okay. So let's just move this pointer up against our pin and our crank and count over 16 holes. I'm gonna hold the stop right here with my thumb, and I'm gonna count 16 holes. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. This is getting tight. I don't know why. Let me reset this crank. Let's see here. That's better. All right, let's start again. Back up to the top. Okay, 16 holes. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right there, okay? So we'll lock this guy down. Okay, now here's my 4/5 of a turn. If I start up there, go around to this stop on the other side, that's 4/5 of a turn. And for my next division, I just run this thing around and do the same thing. Drop it in the hole. You just work your way around the part that way. Okay, see how it works? So each one of these turns that each one of these movements that I'm making on the crank is moving my, rotating my part 1/50th of a revolution. Okay, pretty cool, huh? Pretty simple, actually. So we just work our way around, and then we'll cut a division at each one of these locations. Okay, it's you know, it's a lot to keep track of, but as long as I like to keep my thumb on this thing when I move it, so I don't lose my count of where I am. You know, don't bump this thing and end up putting it in the hole next door or something here. Okay. And if you think you make a mistake, like I said, you can just go back to your first division and line the crank up with the mark up here, and then you can start over and make sure you didn't screw up somewhere or miscount. So now that we have that figured out, let's cut some divisions. Okay, so first thing I'm going to do is put the pin in this upper hole. Yeah, that'll be our first division, and then I'm just going to bring the part out to the tool. Can you guys see that on there? No, you can't. I got to change the camera angles. Okay, so hold on a second. All right, that should be a little better. I don't want anybody complaining that they can't see what's going on. All right, this shouldn't be a problem. Okay, now I'm just going to bring the part out until the tool scratches the surface. Right there. I'm going to set my y-axis on 0. So like I said before, we don't have to center up on the y. Okay, now I'm going to move in 6 thousandths, because that's the depth we calculated before to get our 3 thousandths width on these divisions. Right there. Alright, so this will be the first division. I'm going to put a little bit of oil on this surface, because we're cutting this tool as a sharp point, and I want a little bit of lubrication on it. I don't want to break it off. Alright, so let's cut our first division. This is going to be a full depth, 230 thousandths. Just like that. Okay. Now I'll move over one division, our 4/5 of a turn. But I don't want to go full depth on this. I want to go 160 thousandths or 70 thousandths less. So what I'm going to do is put a spacer in the quill stop to keep it from going all the way down. And I'm going to cut my next division. Okay. Now I'll move 4/5 of a turn. Spacer still in. Cut my next division. 4/5 of a turn. Next division. Try not to lose count. Let's see, 1, 2, 3. Okay. 4/5 of a turn. Alright, now 1, 2, 3, 4. This next one's going to be full depth. So leave the spacer out, make it full depth. And continue on. One thing that dividing does is it requires your full attention. So you can't have people coming in and bothering you, or the phone ringing, or anything like that, because you will make a mistake. Matter of fact, if I get through this while making a video without making a mistake, I'll be pretty happy. Okay, where are we at here? 1, 2, 3, 4. This is a deep one. Yeah, you guys should be on the other side here. You can see all these nice divisions. It's pretty cool, huh? Alright, this is a short, shallow one. Another shallow one. Or short one, I should say. One, two, three, four. Next one's deep or long. Make sure I got plenty of oil on that thing yet. It would really tick me off if I broke the point off this tool halfway around. And full depth. Every 5 divisions I end up with the crank at the top again, so that's easy to keep track of. These dividing heads, you can set up just about any number of divisions. I have, I don't know, half a dozen different plates with various hole spacings on them, hole circles. And if I need something that I don't have a plate for, I can make a plate. 2, 3, 4, 5, yep, all the way down. So they're a pretty versatile tool, very useful. I use this one quite a bit. I don't know if you can see the divisions coming around the other side yet. Got to be getting close. I think I'll probably use some magic on this video when I edit it and speed up some of these parts so you guys don't have to set through the whole thing. Or maybe I'll just make you set through the whole thing. I have to. Only sounds fair to me. Yeah, and always keep backlash in mind on this, because like any other gear train, this dividing head has a little backlash, so if you go too far, you know, you go past the hole you want to stop at. Don't forget you have to back up and come back to it again. You can't just back up and drop in the hole. You got to go past it a little bit, take the backlash out. Alright, we're just about to the end here. I see the end of the tunnel. Hopefully it'll end up in the same place it started. Always a good thing. And there we are, back at the beginning. So that's it for the divisions. What I'll do now is I'll just pull it off and throw it in the lathe and just polish this up a little bit to take the burrs off. Other than that, next thing in line is the let's see. Well, we have the numbers to stamp yet, and we also have that 1/8 inch reamed hole on the end. Is it this end or the? Yeah, actually that's on this end. So I'll go ahead and do that right now. Drill and ream the 1/8 inch hole. So let me change the setup, and I'll be right back with you. Okay, so got the chuck back in. For drilling and reaming this hole, we need to know where the center of the part is. So I could have left it set from before, but it doesn't take much to pick it up again, so let's recenter the y-axis here. Alright, so now this hole is for a spring and a 1/8 inch ball. All it does is put a little bit of drag on the thimble so it doesn't move around if it gets bumped or vibrated. So it's not real critical. I don't know, I'm not sure why I put a +1 -0 tolerance on the hole. I guess just so the ball would fit in. But it could just be a 1/8 inch drilled hole as long as it's big enough for the ball to go in, but we'll follow the print. Okay, this hole is 0.375 from the center. So we'll crank out 375, leave the X on 0. Right there. And the hole is 270 thousandths deep. So I'll just drill down to its full diameter. Set my quill stop. Bring the cable up. 270 plus a little bit for the reamer, the end of the reamer, and drill it in. And this is a dowel pin reamer. It's a 1,000th oversize. So I'm just going to run that down until it touches the hole. Set my stop. Now I'll crank up to 270. So we'll ream it to the 270 depth. That'll satisfy the print. Okay, so that's about it for this part. There's the hole in the end, all the graduations. So now I'll put it back on the lathe and just clean off the burrs here. Just run a piece of Scotch-Brite over it, and I'll take all these burrs off nice. And I'll press the mandrel out, and the next setup we'll do is we'll put together a fixture to hold this part so we can accurately stamp the numbers on, make them look nice. And I'll show you how to do that in the next video. See you then.